Hello mathematicians, we're now going to have a look at the perpendicular distance formula. And what the perpendicular distance formula does is that it gives you the perpendicular distance from a point to a straight line. And the perpendicular distance is always the shortest distance between a point and a line, and that's how it's often phrased. Now the formula is given here. It's just a matter of substitution into the formula. So there is a proof given in your textbook. We don't need to be able to prove it. If you're interested, have a look, but don't try and commit it to memory. But all that we have to do is make sure that we identify what the A, B and C are that we plug into this, and what the X1 and the Y1 are. So if we remember that the point is X1, Y1, and the A's, the B's and the C's come from the line written in standard form, we should be okay. And don't lose the absolute value signs. The absolute value is there because we're just interested in a distance. So we don't care about direction, we just want to know how far. So these examples here. So we want the perpendicular distance from the point 2, 0 to this line. Now it's important to check that the line is written in standard form, because that might be something that they will throw in to confuse you. But once we have checked that, then this is A, this is B, and -1 is C, and this is X1, Y1. So we just go to our formula. The perpendicular distance is the absolute value of AX1, so 3 times 2 plus, and always put a plus in here, and then take care of the signs later on. So plus 4 times 0 plus C, which is -1, over square root of A squared, which is 3 squared, and even write this. Even though you know in your head that the answer is 9 and 16 and the whole thing is 5, put your working in there. So 3 squared plus 4 squared. Now the reason we don't have to include our absolute value signs all the way down is that, remember, by implication we take that as positive, the positive square root. So our top line is, we want the absolute value of 3 2s is 6 plus 0 -1, so that will be 5. So the absolute value of 5 over 5, which is just going to be 1. So this point is 1 unit on one side of the line. Now if we had actually got, if we picked a different point, plugged it in, and this had come out to be negative, it simply means that that other point is on the opposite side of the line to 2, 0. Okay, our next one here, just really quickly, perpendicular distance is absolute value of A, which is 1 times X1 plus B times Y1 plus C over the square root of 1 squared plus 3 squared. So our top line becomes -3 and -6 is -9. Plus 4 gives us 5, and square root of 1 squared plus 3 squared is square root of 10, and we should rationalise the denominator. So multiply top and bottom by root 10 and cancel it down, so it's root 10 on 2. They could be really nasty and allocate a mark to that bit. Now I'm only going to do one of each of these next examples, leave you the other one to have a little practice on. So I'll do the second one out of each one. So write down the centre and radius of each circle. So for this circle here, we can see that its centre is going to be at 1, 5. So centre 1, 5, and radius is going to be square root of 10. So we then use the perpendicular distance formula to determine how many times this line intersects the circle. So this is much more like a thinking thing than plugging in. So what's the idea behind it? Well, if we've got our circle, no matter what it is, if we get the perpendicular distance out to a line from the centre here, and that perpendicular distance is bigger than the radius, then the line doesn't cut the circle at all. If the perpendicular distance just equals the radius of the circle, then it's just touching at one point, and if it's less than the radius of the circle, then the line is intersecting the circle at 2 points. So that's our logic behind it. So really, this is a long-winded way of saying use the perpendicular distance formula, and draw some sensible conclusion from it. So step 1, therefore, is to find the perpendicular distance. So that will be A, which is 3, times x1. Now the point we're interested in, as we said, is the centre of the circle. So it's 3 times 1 plus b, which is minus 1, times y1 plus c, which is minus 8. Absolute value of that over the square root of 3 squared plus 1 squared. So that's going to be, so here we have 3 minus 5, so that's minus 2, minus another 8 is minus 10. Absolute value of minus 10 will of course be 10. That's over square root of 10, so that's 10 on root 10, which comes down to root 10. And that equals the radius in this case, so it's this situation where this line is just touching the circle at a point. We know that title for it, you don't have to know it for this question, but that makes that line a tangent to the circle. And tangents always intersect radii of a circle at a right angle, as you'll see eventually. Okay, next one says use a point on the first line to find the distance between each pair of parallel lines. So first, and this again is an application involving some good maths understanding. So first thing to notice is that we can see these lines are parallel because the A and the B values are the same. And if two lines are parallel, and we want the distance between them, what we want is the shortest distance. So it's the perpendicular distance from a point to a line, where the point is just one of the points on this other line. So we wanted a point on the first line, this one here, to be able to find the distance between that line and this line. So our only tool is the perpendicular distance formula plus our understanding of the situation. So we need a point. So how do we find a point on this line? I can hear you say, well, because this line extends on to infinity in either direction, we tell it what value of x we want, and we figure out the value of y that would be such that it was on this line. So pick some easy numbers. So it would probably be easiest to pick like x equals 0 as our first point. And if I put x equals 0 into this, that gives me y equals 2. So when x equals 0, y equals 2 is a point that exists on this line. But I could have picked literally anything, like x equals 1, and then solved it to get the y value. But the main thing is I've now got a point, 0, 2, which is on this line, and I want to know how far that point is from this line, and that will tell me how far apart the two parallel lines are. So we use our perpendicular distance formula again. So our perpendicular distance is going to be absolute value of A, which is 4, times x1, plus B, which is 1, times y1, plus C, which is 8, over square root of A squared plus B squared, 4 squared plus 1 squared. So we've got 0, plus 2 plus 8, 2 and 8 are 10. Absolute value of that is just 10, so it's 10 over root 17, which becomes 10 root 17 over 17. Now, have any of you asked yourselves why this method only works for parallel lines? the answer is, of course, that if the lines weren't parallel, going like that, the shortest distance between the two lines would depend on either where the point was, which meant you couldn't just pick one at random, or the logical conclusion is they must intersect, so the shortest distance is 0. Okay, so have a go at 5e.